What we're saying is from an architectural point of view, this is a single unit. But the nice thing is this team looking after Salesforce has minimal things to do. Having the ability to replace systems as needed and not having to sort of create more code on top of more code on top of more code, you're able to keep your system simpler and more reliable and not really build up tech debt over time. Welcome to Delta Flame Fireside. Today we'd like to introduce you to the architectural framework we call Delta Mesh. In this talk, I'll give you a high-level overview of the framework and how it might fit into your organization. And in later talks, go into more detail and more background and so on. As this is the first video, I thought I'd give an extra introduction. It's a lovely Melbourne morning here. The two main things I want you to take away from this upcoming talk are how to remove and prevent tech debt, and how data is not really worth having if you can't prove it's correct. Okay, over to the studio. So firstly, let's start with who's this for. So if you're the kind of person who really looks for quality and simplicity, and you really look at products and try and sort of imagine how they'll work and how they'll wear and where the problems might be, and you like a product where there's not really any surprises, like it's obvious that it's going to do the job, it's going to last, it's well designed, this is for you. And in terms of who the framework's for, it's for medium to large organizations, any organization that has multiple teams, but the principles can also be applicable to any organization that's working with data integration and so on, and particularly if you're looking or expecting your company to grow. So let's have a look at some of the reasons you might want to adopt a new framework or some things to look out for, and what are the problems that are out there that are common and that we're trying to address. So one is different speed teams. So when you've got a project, you might have the backing of the CEO, you might have extra consultants coming in and so on. And really that project needs to be smashed out, whereas it might rely on data integration with other teams, other products, and they don't necessarily have that same funding or time or priorities. It's possible and common for reporting to be left till an afterthought. Whereas if it's built in, that's obviously advantageous. Another one, and this is just a general one, different answers to the same question, so that we might have different copies of the same information floating around that don't necessarily agree, and it may be difficult or impossible to even work out how that happened and how to fix that. Applications difficult to replace. So we'll get into this more later, but what we really want to have is software at a small scale and software at a large scale that can be sort of pulled out, new one plugged in, and everyone keep going without sort of too much disruption or regression testing and so on. So another one is overloaded APIs and locked databases, etc. So when we're looking at architecture and we're sort of planning for the future and planning for loads and things, we need to make sure that we're not going to have systems go down or get overloaded or get locked, just otherwise cause problems, right? We want to go live and things are great. And so particularly between teams, that can be a problem. And that can be one of the reasons why we sort of want our quote unquote own copy of the data, or we'll get into how the architecture addresses that as well. Data simply not available. Again, that could be for a number of reasons. One of them might just be that, the team that would otherwise provide it just doesn't have the time. So that can be a problem when you start to look at alternatives. And yeah, we cover this a bit as well. So just being able to trace data. If someone asks a question, they log a support case. How can we close a support case? How can we answer a question quickly such that we maintain the trust in the data? Some other things to think about. A new CEO can come along at any time. Your company could get acquired at any time. There could be a new project that comes in. So essentially, when we think about our architecture, we don't want to write everything down and put everything in a neat little box. Ideally, the system assumes from the start everything's going to get replaced, everything's going to get changed, and it just works with that. It's designed from the ground up to contain that kind of flexibility and to allow someone new to your organization to come in, understand quickly the part that they need to work on and be able to work without, again, regression testing and so on. Some other things to think about is if you want to introduce a new architecture to a company, any company, there's going to be some trade-offs. There's going to be some costs, obviously, hopefully a lot of advantages. But these are some of the things that you'll expect to see. So one of the things about the Delta Mesh framework is you really can introduce it in small steps in any project. It doesn't take a lot, and you actually see a lot of benefits almost instantly. So you can actually just take like even one project and you can just build it with this architecture, probably about the same speed you would have anyway, but you've now laid out the ground, the foundation to start rolling it out to the rest of the organization, and you've proven the technology. So just a quick note on the name and a good way to think about it. The name Delta Mesh is obviously a bit of a play on data mesh. They are actually quite different, although there's a couple of things they share. And probably the best way I could put it is one is open source and one's closed source. So one of the things in data mesh that we talk about is data products, which can be good, and I'm sure there's a lot of really good ones out there. Where they fall down a little bit is in so much as you can't necessarily see the working, you can't see what's going on underneath. So it's harder to trust the data. And like we talked about before, we can have different speed teams. We can, we can really have the capability and the capacity to really understand, but it's all closed off. And teams don't necessarily share everything. And even if they do, it's harder to make changes. So one of the things we do in Delta Mesh is we approach the working and everything a bit more like an open source project. And we'll go into that a bit later, but you can see the raw data, you can see the inner workings, and you can actually contribute to them. In terms of background, you don't need to know all these things. If you do, that's great. That will help, because there's a lot of ideas from most of these that are borrowed or reused and so on. If you do nothing else, I suggest you watch those two talks by Greg Young. Event sourcing, I watched that, I think, maybe 2016, 2017, and it's just been a secret weapon ever since. It's fantastic if you haven't come across those concepts before. And The Art of Destroying Software is a really nice way to explain some of the concepts that are baked into this architecture. So that they're not just small pieces of software, but even the entire blocks of software themselves, being able to just take them out, replace them as needed without too many strings. And we'll talk to this as well, how just the team that is working on it can work on it in isolation. And here's a quick high-level look at the architecture. So we'll break this down and we'll go through it piece by piece. And just a quick note on standardization. So something like a brand new MacBook Pro can still plug into something that was standardized like 120 years ago. So some of these standards certainly make life easier. Certainly they allow different companies, different people to effectively work together without having to talk to each other. So the framework looks to maximize flexibility, and we'll get into that as well. But there's certain things, particularly where with the idea that teams aren't necessarily going to talk, we necessarily have to standardize on some things. So the goal has been to minimize those and to also pick the ones that are in really, really common use, ideally are open source and have proven themselves and have widespread adoption. So it's possible that decades from now, some of this will change, but the idea is that we can actually, for a long, long time, lock in on some of these standards. All right, so let's start with the component that we call the apron. Now, I've got this slide. So what do we mean by apron? No, not the clothing. If you're familiar with airports or just engineering in general, I'll just read it out. So the functional service or buffer zone that supports operational, structural, or environmental requirements. So in other words, in the case of an airport, it's the concrete that goes around. So, and the way we look at that is, if you have an application that's made up of perhaps microservices, and that's very well architected and working together and using a common stack, and it's all, modern or perhaps not modern, what we can do is we can put an apron around that, and effectively we don't touch it. And there can be other components in there as well. I'll go through some examples of those soon. But what we're saying is, from an architectural point of view, this is a single unit. a single context. And the architecture isn't really suggesting any changes inside the box. And so when you're looking at designing things, or when you're looking at classifying your existing infrastructure, applications, and so on, this is just a way that you can sort of think about it and approach it. And the architecture itself will suggest certain things based on how you've drawn those boundaries. So a good example is software that you've only got limited access to change. So if you've got Salesforce, and if you ever work with Salesforce, you'll know that the loader is quite a common component. So you can install it on your desktop and you can upload CSV or whatever quickly into Salesforce as if you'd typed it in, kind of thing. And so in this case, I would say that that's inside the Apron. So we're not suggesting that, hey, if you adopt this architecture, that you've somehow got to change the way you use loaders or not use loaders or anything like that. It's encapsulated. So once we've defined our aprons, the next thing we do is we take whatever information is relevant to the rest of the organization. So there's some amount of work has to go into cleaning it up, and that's abstracted. But we just push that data into the raw layer of a Delta Mesh domain. And there's a few rules around that, which we'll go into later. But essentially, it's a push activity, and the component that we use to do that, we call a nexus. So the next step you'll be familiar with if you're familiar with medallion architecture. There's a couple of extra things that the architecture specifies, which we can go into more detail later. But the main thing is we take from raw, which is append only, and we curate that data, and we write it to what we call the data hub. So it goes into nice, clean tables. And again, a bit later, I'll go into a bit more detail how that works. But that's the basic flow. And this is done with PySpark, and it's done, you can think of it in an open source type way. So the entire organization has access to this raw data, and they can also see exactly how it's been processed. And just a quick note on when we mentioned Python here, it's largely to do with data virtualization, but we'll cover this in more detail in later videos. So the next thing I want to talk about is the hub data. So what are we talking about here? If you're familiar with a data hub, that will sort of give you a bit of a background. But essentially, we're talking about the information. Okay, so not how we move it around, not JSON, not APIs, anything like that. We're talking about information that's interesting to the company, regardless of where it comes from. And sometimes similar information can come from different places. So the example I like to give is sales. You can have multiple channels that you sell through. But what we're trying to do is to keep that similar information together. So in the case of sales, you might only want to have one table, and you might have a column to say where it's from. And this is cleaned up. It doesn't have remnants of the source system or anything like that. It's just the pure data. And part of the reason that we do that is because we don't want the rest of the organization, whether they're doing integration or reporting or whatever, to have to become an expert in the source system. So we want to just have essence, and we want to use clean naming and so on. And the other nice thing it gives us is the ability to change the source systems, but still flow the data through to the same place. And hence, we're not affecting downstream systems. So if we have our data centrally available for the entire organization, there can be very, very different loads and so on that are put on that. And we don't want to have half changed or half updated. There's a whole lot of things that we want to sort of ensure are true. And the question is, well, given that we've got this goal of central information, how can we support that? So what the Delta Mesh proposes, as you can kind of get from the name, is the Delta Lake format. Is actually a data lake based database. And with that, you get all the sorts of things you'd expect from a database, and a few extras which are required to actually make this work. So, and I should mention that there is some competing similar standards. And as we go forward 5, 10, 15, 20 years, there's probably going to be more. But this is a well-established, well-approved standard. And as we talked about with the power socket, we really do need just to pick something and stick with it for inter-team use and to simplify how teams can work together. So quickly, asset transactions. So yeah, you can be writing an update and only get halfway through, not commit it, no one's going to see it. So there's a lot of situations where that's necessary. For example, if a reporting system is pulling data, there may be related tables. You want to update them both at the same time. So time travel is a nice one. You can see as was. So if perhaps full change data tracking isn't supported, you could actually just look at the database exactly as it was. For example, a week ago, look at it now, calculate the difference, do things like that. It's an open source standard. So based on that, like there's no vendor lock-in. And for that reason, we feel it's a good base format because particularly the raw data, but the entire data platform we're looking at, keeping for decades. And a really big one is the sheer speed that you can access the data. So because effectively under the covers, the data is stored as files on a data lake, those can be served up at tremendous scale to many, many teams simultaneously. And the effective database actually runs on the compute of the client. So things like overloaded APIs, locked databases, huge expenses coming to the team providing the data or creating the need for us to charge to access the data start to melt away because it's just there. Read it if you want it, don't read it. And it's quite straightforward to scale. So let's have a look at how we access the information in the data hub. So we have reporting domains and we have various aprons, and this is, there could be any number of them. And the idea is that, we've got this information, we can access it at scale, and it's distilled, it's also unopinionated, and we actually pull out what we need. And there's a lot of things that come with that. So one of them is when we do so, we can actually join information from any number of tables across the organization. And we can have confidence as well that a bit like some of the data products that we've talked about, once we bind to them, they're going to be maintained. So the data is going to flow in from various different places. And over time, that's going to change or things are going to get corrected, but we'll be able to sort of have a bit of a contract on the structure of the data that we can expect. And the other nice thing we talked about with it being open source effectively is that if we have questions or we do need that extra field, we can go in, look at the source code, figure out what needs to change, make that change, test it, and then do a pull request. So the central team that's looking after the Delta Mesh domain, they just need to do a couple of checks, and then they can incorporate that, and then we'll see that data coming through. So it's a really good way for teams to work together. And if you're fixing a bug or you're just enhancing the data in some way or taking information that a certain team owns and making it more useful to the organization, they're hardly going to complain. Effectively, you're making them look better, but you're able to move at the pace that you need to move. So that's the data, but we pull it out and we join it and we filter it and so on. So, it's not up to the data in the data hub to be filtered. Ideally, it's not at all, but you filter it and you join it as you need. Within a reporting domain, you might do what we call processed or goal tables, but those are your own. And we'll look at some of the reasons why you might do that later on. So we've talked a little bit about trust, and we've talked about tracing issues. So if you get a support case or you have a new requirement, but particularly when there's problems, you really need to be able to go through and either find the problem or prove that the data is actually correct. It's just not exactly what the business was hoping for. So that's a big part of what we do with the sort of some of the open source stuff we're talking about. All right, so let's jump over a little bit and just look at integration. So something that to a lot of organizations may be a little bit foreign is having this data platform and not just talking about analytics. We're not just talking about traditional data warehouse things. So we've talked about Delta Lake, as the underlying database system that we use to access the database. And that changes the game a little bit. It means that we can have this one single source of data, and we can use it at scale from lots of different teams without sort of too much concern about overloading or locking or reading half-up data or anything like that. But it also unlocks the possibility of using it for real-time integration, and not just real-time, but integration at enterprise scale. And one thing to note, I guess, with that is it can be tempting to sort of think in smaller memory-based terms and to sort of go, well, I'm not so sure about a database. Sounds like it might introduce some lag or, some problems. Now, there is some very, very real-time or temporal coupling things that we'll talk about in a little bit as well. So there's exceptions. But generally, when you're talking about really big enterprise scale, being able to use powerful tools like Spark to process thousands and thousands of records at once starts to become necessary. And when you start to zoom back just a little bit, like you might be talking about every 5 minutes, how much can I process? Then things start to change a little bit. Or you think about, well, what if I get a huge amount that comes through? Or what if I have an outage and I need to catch up and now I need to process like 20 million records? How long is that going to take? So you start to look at the average delay and things like that. And other things to think about is, and this is, what managers and the larger organization would think about as well, is if you've got perhaps a 24/7 operation and you're making changes and potentially you're introducing bugs, which is guaranteed at some point, you really need a very, very calm and collected way to figure out what went wrong and fix it. And when you when you adopt the principles of this framework, you're actually able to do that. So you can actually make the changes you need to make. You can make them quicker. You can fix them. You can keep moving. So once you understand and apply these concepts, you really will find many unexpected benefits. So let's quickly talk about request, capture, event separation. So, and this is related to CQRS, if you're familiar with that. When we want to make data available to the rest of the organization, we push it into the raw layer and we show our working, sort of open source, as I like to say. We curate that data, and that's where the rest of the company will pull it from. But the other thing we can do is not just information that we have, but something that we want to happen. So this is the request. Okay. So a system may not be authoritative in a particular area. So, with big organizations, we have different systems. It may be that it wants something to happen. Okay. So we could have, an app or whatever it happens to be, and we have maybe an ERP system in the background, and we want an order to be created. But that app is not authoritative of an order. So effectively, that order doesn't exist, but something exists. And what we would say that something is a request. So that can be pushed in raw form. So, we like to keep things raw and all the fields, all that kind of thing. We push that in and we curate that. So what we have is, in this case, a request for an order. And it could be 50,000, it could be 20 million of them, whatever, right? So they're flowing in, streaming in, however you want to look at it. And we can have a system. So in this apron over here, it might be our ERP system. And so we can pull out those, like extract from those tables, using a watermark, using whatever, all the requests, and we can create them. So, and we don't really have time in this talk to talk about it too much, but as that happens, we actually create events each time. So for each record, we'll actually say, hey, I did create this, I didn't. And those events actually go back to raw as well. So they are available technically to the rest of the organization. But as with just about anything, you don't really want to have to be an SME. You don't really want to have to understand this software, this integration, whatever. You just want to kind of know, well, we've got this table of requests, but are they actually orders? And what order numbers are they? And so on, right? So again, those events, we can actually process them back through. And now we have 2 tables, right? So we have the original requests, nice and clean data available to the entire organization. And we have the status of them. So were they created? Were they rejected? Are they pending? Those kinds of things. And if there's any questions as to how that works, again, open source, you can have a look at the PySpark and figure it out. Now, there is a little bit more to this, again, probably for another talk, where we can actually have a virtual view. And that's where we virtualize some tables with a Python library. But again, I'll save that detail. So the main takeaway I want you to have is that each system or collection of systems inside an Apron is going to have master data, it's going to have transactional data, and it's going to push those into raw, as we've talked about. But it's also going to have requests, so things that it wants to become records. And what we're suggesting is, if at all possible, push those in to the data platform as well. And the nice thing too is that means they're immediately reportable. So let's have a quick look at some of the extra components in a Delta Mesh domain. And I should mention that you can have multiple domains. It really depends on the organization. So we've got Python libraries mentioned. We've talked about them briefly. We've got Apache Kafka. Now, there's a few things for that, but just briefly what I'll say is we like to be event-driven. And there can be, when you're talking about different teams, different technologies and stuff, so Kafka is a open source standard. When you do things like write to a raw table or write to a hub table, like you update them, what we would say is put that message in Kafka in a stream, and that just allows a lot of things to be possible that we can go into detail later. The other is Apache Atlas. So in Microsoft land, you might know that as Purview, but essentially it's a standardized way to create a catalog of what's going on, and also to trace how data was flowing, visualize it, and so on. So let's start with an organization that has, for example, Salesforce and Dynamics 365, so the ERP. We'll throw in our Delta Mesh domain. And something that I should mention is we don't have to do everything all at once. So if you wanted to start with 10 tables, or you've got a particular project in mind, maybe some reporting requirements, or whatever, you can just start with that data, go through, figure it out, get it going, get quick value from it. But everything you do is going to help future projects. So that will be a compounding benefit. So the more projects you do, the more advantage you're going to get, the quicker you'll be able to do later projects. So we get some data in, and as I mentioned, we curate that data. So while the organization can see the raw data, they can see the workings, so maybe the PySpark that's cleaning it up if they need to. Ideally, they don't need to. Then they access the cleaned up data. So let's throw in a reporting environment or reporting domain. So the idea is that it's pulled out. So you just pull what you need. You can join it. You can filter it. Because as we say, the data hub tables they don't have an opinion. So filtering them would be an opinion, for example. And if we have another one that's either new, or we just simply have 2, don't have to worry about the load or breaking the database. And we don't have to worry about breaking changes, because as we've mentioned, everything's quite traceable, and any team can actually jump in and find the problems and fix them. Ideally, it would be the team that's actually in charge of it, but it's nice that everyone can actually see what's going on if they need to. So if there is a new field or something's changed shape or whatever, usually it's just a case of make a change and reprocess the data, and then it's available for use. Something else that's nice, it's not just about reporting, it's also about integration. So if we find that we need to sync some records from, in this case, 365 to Salesforce or vice versa, we can follow the process we've talked about to get them into the data platform, and then they can be consumed without necessarily having to worry about all the underlying complexity of the system, or maybe the API limits, or all sorts of things. It's just, there's the data, no opinion, go for it. So let's make that a bit neater. And let's throw in a field service application. So this might be built with microservices. It doesn't really matter, any language, whatever. It's encapsulated, as we talked about, in the Apron, and we'll put a nexus in there to enable us to work with this architecture. So, and if you can imagine that was a new application, that team might just be able to go through, find the data that they need and just start importing it. So they didn't really even need to talk to anyone, just straight away, they've got that data, they've got value, and they haven't just got the data, they've got it in a way that it's going to be updated. And if they've got questions, maybe they're not sure how often it's updated. So they can actually just go and look at the raw data. They can look at, they could make a request to the relevant team and say, hey, this is great, but coming once a day, could we get it every hour? And that kind of thing should be possible. And it should also be possible with permission for them to actually assist some of the work, like I said, to keep things moving. And whatever information is relevant to the rest of the organization, we're going to push into raw and then, of course, curate and so on. And one thing that I'll mention here is, and we alluded to this earlier, sometimes you do need up to the millisecond information, and sometimes you do need to do something in another system. So get postage or, in some way create a transaction that the user is going to be able to immediately see. So for this, we call this component a tether. So temporal coupling, so that just means that related to time, it's happening at the same time. We also find that this is applicable to sensitive data and digital assets. So if you've got, personally identifiable information, your life's going to be a lot easier if you don't actually push that into the data platform. So it's not in raw, it's just not in there. So if it's not there, it can't be hacked. But what you can do is you can push in the metadata, and that can be synced at scale, that can be filtered, that can be joined, all the nice things. But at the edge, so when you actually finally need it, so let's just say with personal information, if you're actually writing it to a target system, you can right before you actually send it, is you can make a call out using the metadata, grab the actual detailed information and write it, and that particular part can be secured. So you might have a certificate or something, and it might only be happening in production. And same with digital assets, they can get out of date. You might want different resolutions and different things. So best to keep that out, but push the metadata in, and again, just fetch it just in time. So how that looks is we introduce an intermediate component, and it a bit like an Apron, it can be built with any technology, right? So I would often suggest something like Logic Apps, something visual, quick to build, whatever. But the idea is that when a request comes to it, that request is in terms of the client. So it's simple terms. Think of it like an API. It's like, hey, I want this nice JSON request or whatever. This other half of the equation can be whatever's required. So there could be an SDK, there could be whatever. So we're not really going to put any restrictions on the developers. They just need to say, this request needs to happen, do it however it's done. But in having it separate like this, that opens up some possibilities to us that we'll discuss a bit later on. It is starting to look a little bit busy, but the important thing is it's flexible and it's traceable, and we can do things like replacing applications. So let's have a quick look at that. Let's just say, and this was probably one of the hardest things to do, we needed to replace the entire ERP system. So in this example, let's just say that we've actually had Delta Mesh for a while. It's fully realized. So all of our interactions are either going through a tether or request capture event separation, which we covered earlier. But there is situations where we need to do both. So let's just have a look at how NetSuite would be connected. So we've obviously got raw data coming out of it. That's fine. So that's going to be NetSuite specific. But when we curate it, what we need to do is we need to curate it into the same table, so the equivalent. And there might be a couple of minor issues, and that's unavoidable, but they're going to be minimal and potentially not at all, right? You can have nulls and things. So that's one part of it. And the team who's working on rolling this out probably doesn't need to talk to too much to the rest of the organization for that part. They can just build that in and then maybe get some basic testing done. Then we've got a tether from Salesforce and we've got one from our field service app. So what we talked about before is when this app wants something, for example, it can, it's requesting it in simple terms and then whatever's required. So there might have been some sort of Dynamics SDK or something here, but the team responsible for this, they actually need to grab this, understand it, open up the code base. So we say it should be separately accessible and just rebuild that and just make it do whatever needs to happen, right? But the nice thing is this team looking after Salesforce has minimal things to do. Okay, so they might be involved in testing a little bit, maybe there's a couple of tweaks, but essentially it's this team that's going to work here, this team that's going to work here, and that's applicable to if there was any other tethers, any other tables, and so on. And the really nice thing is the data actually coming in, which could be 50 tables, could be 100 tables. That might already, and maybe over 10 years, it's being used in lots of reports, it's being synced to our field service application and so on. But so long as we can recreate those hub tables, everything's just going to work. And I know this is a concept that we've talked about or has been attempted in various different ways over the years. But where I think it falls down is we really try and just force standardization or try and predict the future too much. And we haven't had technologies like Delta Lake where we can have that single source. So where this is different is we're not, when for example, we first create things like these tethers, we're not trying to create some universal API and predict all future possible things and foregoing all nice ways of connecting. We're just making it work in whatever technology. And we can just, if you refer back to Greg Young's The Art of Destroying Software talk, we can destroy this. We can just replace it. It's fine. But the key thing is the work for the team involved is finite, encapsulated, and we know what we need to test. We know when we're done, and we know that we're not, treading on other teams' toes. And we also don't have to say, hey, we're going to implement NetSuite, but by the way, at the same time, we need to learn everything else about the entire organization, get all the logins, all those sorts of things. So it's abstracted, but also when all this stuff was built in the first place, things were still quite straightforward. So when it comes to defining some of these hub tables and things, you can just ask the business. It's say, well, what is this information? How do you think about it? How do you, maybe look at an invoice, whatever. You can start to understand what the technology is. So it can be rolled out progressively, used immediately, and has increasing and compounding benefits over time. So I guess some general things to think about. We've got quality, as we talked about at the start, which can actually be quite a lot cheaper. So if you're not spending a lot of time tracing issues, you're not having to reinvent the wheel for new projects just because you just don't trust that you'll be able to get it or it'll be up to scratch or whatever. You're going to save money. As we talked about, trust. So it's open source, so we can see the raw data. We can see how it was processed. We can make some changes if we need to and do a pull request. And so we can collaborate. And if we've missed something, that can be caught or that can be rolled back as well. So we've got reliability. So one of the things is about keeping it simple and having less moving parts and having it more predictable and spending less time just trying to understand what's going on, is we can spend more time making it reliable. So less is more in that sense. Openness, we've talked about a fair bit, and flexibility. And one thing that's sometimes overlooked about flexibility is having the ability to replace systems as needed and not having to sort of create more code on top of more code on top of more code. You're able to keep your system simpler and more reliable and not really build up tech debt over time. It just kind of is what it is. You just keep working with it. So in future talks, we'll cover how we've implemented this. So we'll go down a level lower. We're working on a wiki and a website that we'll be launching soon. So by the time you watch this, may already be up. And we're looking at how best we can capture questions. So we really want to be here and answer anyone's questions over time so that you're clear on everything. And as you implement it, you can also let us know how that went, feed that back, and the community will learn together. Thanks for sticking with me to the end of the video. I hope you've got some value out of it. I hope this has tweaked your interest, and I hope to see you again in the next one.